like we are still in chopper. Okay, so we'll try to look into this. Okay, in last class we have been seeing a different type of choppers. Okay, and what is the advantage of a different type of choppers? How does it operates? Okay, and we knew that the choppers are the most simplest type of converter. Means we are converting from one form to another form. Okay, and these are we have classified into a different type of choppers: class A, class B, class C, or a buck boost type of or buck boost type. So we know that step off or step down choppers. Okay, and now this is another type of chopper which is known as the impulse commutated choppers. Means that in this choppers commutations is possible. So these choppers are the impulse commut. These are widely used for the high power circuit actually, where the load fluctuations is not large. Means where there is a fluctuation of the loads are not so much. Where the places where there is a constant load, so this type of choppers are used. It means that you know that load will not vary, or the out means that the load is not going to vary. And if you know, if you just want to use this type means this chopper which do not have the variation in the load, then you can use this impulse commutated chopper. And these choppers are also known as a parallel capacitor turn off choppers, where the capacitors are used to turn off the choppers. There are two thyristors in this type of choppers. The one thyristor will work, and there will be an inductor and a capacitor. The charging and discharging of a capacitor and inductors will help to turn off the thyristors. So that is a pulse given to this commutation means you know that to turn off the systems. So it's also known as the voltage commutated choppers, means where the voltage will be mean the energy which is charged in this choppers are discharged. Means whatever the voltage will be discharged, there will be a charging and discharging. So because of this, it's also known as a voltage commutated choppers or a classical type of choppers. So this is a chopper, impulse commutated choppers, where they use these two thyristor T1 and T2 and the capacitors. So when the A is positive with this, so this capacitor will charge, and it will drive means that when you give a triggering, then it will the loop it will flow in this way. So we'll see this. They use a two thyristors, a diode, and a freewheeling diode is also used, and inductors, two source inductors, and the inductors L1 is also used in this one. We'll see this. Actually, there are five mode of operation. I mean, it operates in a five mode. So we have to classify this into a five mode of operation, and this is mainly used that because of with the help of these capacitors and inductors that the commutations can be possible without using the external circuit in this type of impulse commutated choppers. So initially, to just to start with, we have to charge the capacitor. Initially, this capacitor needs to be charged. So charged with the polarity means that with the plate A positive by triggering the thyristor T1, T2. So this, if you trigger this thyristor T2, initially this has to be, this capacitor needs to be charged. Just by triggering this thyristor, it means that the thyristor T2 will start conducting in this case. So capacitor get charged through B, S, C, T2. These are the sequence key. And as the charging current decays to zero, thyristor T2 will. So once this discharging will take place, then the T2 will be turned off. So with the capacitor charged with the plate A positive, circuit is ready for operations. So once this capacitor is charged, then this circuit is ready for the operations. So it means that we're depending on this capacitors actually. So in this circuit, it depends on the capacitors. So we have to assume that the load currents remains constant for during the commutation process. So there shouldn't be any variation in the load. As I've told you in the beginning that the load should remain constant during the commutation process. You know what is commutation? So we'll see each of this mode. For convenience, the choppers are operated in the 5 different modes. So we know that these choppers can operate in a 5 different type of mode. It's like this is the first mode where thyristor T1 is conducting. So in this case, this most thyristor T1 is fired at T equals to 0, and the supply voltage will come across the load. So in this one, the supply voltage will come across the load. So when T1 is triggered in this one, first one, when the thyristor T1 is conducting, so load current flow through T1 and the load. So at the same time, when the thyristor T1 is conducting, the capacitor discharges through T1, D1, so it means like it will discharge through this, and the capacitor reverse this voltage. So this reverse voltage on the capacitor will held constant by the diode D1. So the function is to, what is the, if you are asked what is the function of the D1, so the function of this, whatever the reverse voltage is there, it will held constant. The reverse voltage will remain constant with the help of with the diode D1. So this is how we find out the capacitor discharge current. So IC will be V root of C by L sine omega t. So we know that omega is 1 by root LC. This is a common formula. So IC, we can find out the capacitor discharge current will be V root of C by L sine omega t. So where omega will be 1 by root LC. So the capacitor voltage will be V omega cos omega t. So this is in the mode 1 when the thyristor T1 is conducting. So in mode 2, thyristor T2 will conduct. So this is the circuit diagram how during the mode 2 operations. So thyristor T2 will now be fired to commit the thyristor T1. So when the thyristor T1 is conducting, then at this time the commutations of a thyristor 2 will take place. Means that the thyristor T1 will be, once the thyristor T2 is now fired, it means that it will start conducting, then T1 should stop conducting. So the commutation will take place now. So when the T2 is on, the capacitor voltage reverse bias the T1 and turn it off. So capacitor voltage will reverse bias the T1 and T1 will off at mode 2 operations. So the capacitor voltage discharges through the load from negative V to 0. So it means that capacitor voltage will discharge through the load. So discharge time is known as the circuit turn-off time. You know that there are two different types of turn-off time. One is the circuit turn-off time and one is device turn-off time. Circuit turn-off time should be more than that of a device turn-off time. So we can find out the circuit turn-off time is given by the TC will be equals to VC, the capacitor voltage into C divided by IL. So with this formula, we can find out the capacitor turn-off time. Then where the IL is the load current. So this IL is the load current. So we can, so capacitor turn-off time will depend on the load current. If you see here in denominator is the IL. So circuit turn-off time will mainly depend on this load current. So it must be designed for the worst case conditions where which occurs the maximum value of the load current and the minimum value of the capacitor voltage. So it means that in the worst case, so it's the maximum value of the load current in the worst case and the minimum value of the capacitor voltage. Means that you have to have a more circuit turn-off time. Then if the circuit turn-off time should be more, then the load current should be, so you know that it's in the denominator. So it depends on the load current. So capacitor recharges back to the supply voltage. So again, that capacitor will recharge back to the, once it discharges and it's try to means like stop conducting, commutation take place in a means the thyristor T1, again it should back recharge this with the positive plate A should be positive. It means that you have to mean that it recharges back the capacitors. So this time the rechargeable time, it means that once it's discharged, these are the two capacitor means the circuit turn-off time means that it gets discharged. So once it again it has to be recharged back, the capacitor will be recharged back. So this is known as a recharging time, means discharging and recharging time. So this recharging time will be, so recharging time is given by Vs into C into IL. So recharging time will depend on Vs, source voltage. So this will depend on the capacitor voltage. So recharging time will, so Vs into C divided by IL. The total time required for the capacitor to discharge and recharge. So how much time is required for the capacitor to, if you are asked to find out the how much time is required, if you are design a circuit, then how much time is required to charge and discharge this capacitor, then we can find out total time period will be the addition of these two, charging and discharging time. Charging and charging time is called a commutation time. So this time if you know the charging and discharging capacitor times or capacitor times, then that is a commutation time, and it's given by TR is equal to TC plus TT, which is a recharging time plus the discharging time. So how much time is required for discharging, right? So discharging means that discharging time is, this is the discharging time, means the circuit turn of time, how much time it requires for the, means like circuit turn of time means how much time is required to turn off that circuit. So both this will be addition of the commutation time, means charging and discharging of the time of a capacitors. That's why it's an impulse, means like the name itself is given as impulse commutation chopper, or it can be a parallel capacitor turn off choppers. So means that it helps in the charging and means the turning off the capacitors. So at the end of the mode 2 capacitor has recharged to Vs, means that recharge to means it has fully recharged, and freewheeling diode will start conducting at the end of the mode 2 operations. So in mode 3 operations, this is how it's the circuit diagram of mode 3 operations. So freewheeling diode will start conducting at the end of, if you see at the end of the mode 2 capacitor will recharge to Vs, and the freewheeling diode will start conducting. Now in mode 3 operation, freewheeling diode start conducting and the load current will decay in this case. The energy stored in the source inductance is transferred to the capacitor. Whatever the energy is stored in the source inductance, that will be transferred to the capacitors, and the capacitors charges to a voltage higher than the supply voltage. So in this case, in this mode of operation, in this mode, then the capacitor will capacitor charges to the voltage higher than the supply voltage, means T2 will naturally turn off. Faster T2 will be turned off in this case, where the freewheeling diode will start conducting. So instantaneous capacitor voltage will be, to find out the instantaneous capacitor voltage, which is Vs source voltage plus IL root of Ls divided by C sine omega S by T. So omega S is equals to 1 by root Ls into C, the source inductance into capacitor. So in mode 4 operations, so in this mode 4 operation where D2 will have a function of D2 and the freewheeling diode. So the capacitor has been overcharged. It means that in this case the capacitor has been overcharged. So in third mode of operation, so the energy stored in the inductor will transport to the capacitors in third mode of operation. Now the capacitor will be overcharged. So its voltage is above supply voltage, means that the capacitor's voltage is being overcharged and its voltage is above the supply voltage. So again the capacitor will start discharging in the reverse direction. So in this case the capacitor will start discharging in the reverse direction, and the capacitor current becomes negative. So capacitor will discharge through Ls, source inductance, Vs, freewheeling diode, D1 and L. So when this current will reduce to 0, D1 will stop conducting. So when this current, all this current is becoming 0, then the diode D1 will stop conducting, and the capacitor voltage will be same as the supply voltage, because initially the voltage is, it is more than the, when the capacitor becomes overcharged, then the voltage is above the supply voltage. Now when all the current reduces, when the current reduces to 0, and when the diode will stop conducting, then the voltage will be, the capacitor voltage will be same as the stop of supply voltage. So in mode 5 of operation, both the thyristors are turned off. So it's just working through the freewheeling diode, and the load current flows through the whatever the load current is there, it will flow through the freewheeling diode. So this mode will end once the thyristor is, means that it's just a cycle. Okay, in mode 5 operation, all the thyristors are turned off, and the load current will flow through the freewheeling diode, and this mode will stop operating once again the next cycle when the thyristors turn on. Thyristor T1 is fired. It means that when it starts connecting, the same cycle will start. It means that it does not require additional circuit to turn off the device, means turn off a thyristor or SCR. So it means that the capacitors charging and discharging of the capacitor will help to commute this thyristors. So this is the wave, means like a waveform where we have the charging time, a load IL, capacitor current will be, so it depends on the load current, so it will charge to the maximum current the current will be through this, the current through the T1, thyristor T1. So similarly, the capacitor voltage across the thyristor T1, it will rise from this. So the source voltage plus means the capacitor voltage, it will rise to this point. And if you see that TT capacitor means turn up time, and that capacitor means the charging times are given here. And disadvantage of this circuit is that starting current is required, and starting circuit should be such that it triggers the thyristor T2 first. So it means the starting current is required in this. Means you need to have trigger this thyristor T1. Means that you have to trigger, because initially the thyristor has means the capacitor needs to be charged. So to charge the capacitor, thyristor T2 should be triggered first. So that is the disadvantage. So it means that the capacitor needs to be charged at the initial case. The starting circuit is required, and the starting circuit should be such that it triggers the thyristor T2 first. It means that initially you need to charge the capacitor, and the load voltage will jump to almost twice the supply voltage. So it means that the load voltage will be more than 2 times that of the supply voltage when the commutation is initiated. It means that load voltage, when it initiates the commutation, then the load voltage will be higher than that of a supply voltage. And the discharging and charging time of commutation capacitors are depending on the load current. So that's what we have seen in the formula also. It will depend on the load current, and this limits the high frequency operations, especially at the low load current. So it means that you know that okay, when it charges and discharges, means that there will be a ripple, means that the switching on and off period of the devices. It means that when should we charge and discharge, means like it depends on the how frequently the switches are taking. It's just a switch, right? You know this, the STRs are using, or the thyristors are used as a switch only, that there will be a ripple. So it means that it depends on this start, means switching on and off period also. Charging and discharging times of the load current. So it depends on the load current, IL. So denominator is divided by IL. So it depends on the load current. So choppers cannot be tested without connecting load. So you cannot, because it depends on the load. The charging and discharging current is depending on the IL load factor. So you cannot test the choppers without connecting them to the load. So load needs to be connected. Thyristor T1 has to carry the load current as well as resonant current, resulting in the increasing the peak current rating. So it affects on the thyristor, means when it has to carry the load current as well as the resonant current resulting. So it has to carry both the current. So I have this much slides for this, means for this talk also. Okay. Now we'll see this buck and boost converter. Now this buck and boost converter, okay, actually yesterday I was trying to say, means like make a PPT, okay. I could not complete the whole thing, okay. Now I have just scanned this, okay, in a PDF form, okay. I'll just try to share this. Now I'll just upload this one also. It's not there in the textbook. I got it from the okay. This buck and boost capacitors are, means buck and boost regulators are one of the is quite popular regulators. If you see, if you try to, they means most of the time, okay, means in a textbook that you will find the designing of the buck and boost capacitor, means like regulators, and it's quite popular also. And the buck regulators are a step down choppers, means it's a step down choppers, and the circuit operations are divided into two modes. So what I'm thinking is that I'll solve this, okay. I'll try to solve this in a paper, okay. I'll just screen hearing with the paper, and we'll just see this, or can I just explain from here? What do you want? Can I just explain from this PDF, or
Solve.
you want? Huh?
Solve, sir.
Solve.
Solve.
Okay, let's try, okay, with the screen mirroring. This switch off here. Can you mute here? So we'll try to solve this. Okay, Bock regulator. Now in Bock regulator, okay, this is a circuit diagram. We'll use a BJT in this one. So BJT will have a controller key, an inductor, and this inductor we have the capacitors, and it is connected to a load. Can you see this diagram?
Yes, sir.
Okay, we can connect this to the load. Okay, and the BJT is used. This is Q1. Okay, and this is the source current, and this is the source voltage. Now this is the control unit. Okay, there are two mode of operation. Mode one, Q1 is turn on at t equals to 0. In mode 2, Q1 is turn off t equals to T1. So now in mode 1, okay, if I try to draw a circuit, means a simplified circuit diagram, then the T1 Q is on, then in this case, okay, so this is the load and the voltage across the load, means this is the load voltage VE, and this is the capacitor current, and this is the capacitor, and this is the inductor and the source current IX. So Vs is the source voltage. Now, so input current will begin to flow in this one through the filter inductor and filter capacitor. So this is the filter inductor and filter capacitor. Now and the load resistor. You might ask me that why do you require this filter inductor and a filter capacitor? I told you in the last class also that why do we require this capacitor? Means these are the filters. Means that it generates a when during the switching on and off of this means BJT, bipolar junction transistor, powered BJT. Then there will be there will be a ripple, or there will be a generation of the harmonics. Unwanted signal will be generated, and some of this, okay, means it will help when it generates a harmonics. Means you need to actually, this is a pure DC. We are talking about the pure DC, okay, and there will be a generation within a circuit. There will be a generation of because of the switching on and off of the this BJT. So when it generates, then there requires a certain filter to filter out this unwanted, means that these are the harmonics. So this is a waveform, okay, where waveform, this is a T on period, T on, Okay, T1 and this is T2. So this is in mode 1 operations. Mode 1 and this is mode 2. So this is mode 1 and this mode 2 operations, and we'll have a load voltage, means that this is equals to KT. K is a, actually in this case K is a duty cycle, and you have a current, okay, which will be changing from this to IL, means it means that it will change from I1 to I2. The current will change from, this is a load current IL, so it will from I1 it will change to I2, it will go up to I2 again, it will fall back to I1. So this is a load current. It means that it keeps on there will be a variation in the load current. Now similarly, during the Q1, Q2 is off, this circuit diagram will reduce into this form. When Q2 is off, then it will be L, okay, and this is a capacitors, and it is connected to a load. So this is the capacitor current. IC, it means that when it is turned off. So during turn off time, T will be equals to T1, but during turn on time, T will be equals to 0. So T will be T on. So mode 1 operations. So during the mode 1 operations, okay, the voltage across the inductor L. So voltage across the inductor L in general. So what will be the voltage across the inductor L? So EL will be equals to L di by dt. So this is the voltage across the inductor in general. So to find out the voltage across the inductor EL will be equals to L di by dt. So we can write L I2 minus I1 divided by T1. So with this, L can be written as, so this is change in the current, I2 minus I1 is the change in the current divided by T1. So similarly, now it will change the voltage, means from source voltage minus load voltage. It means when during the mode 1 operation, source voltage minus load voltage will be equals to L del I by T1. Let's keep this as equation number 1. So from this equation number 1, if we try to find out T1, then it will be L del I divided by Vs minus Pa. Let's keep this equation number 2. So T1 is equals to L del I Vs minus Va. Can you see whatever I write here? Or should I focus a little bit more?
No, so
Asti focus go bisa leshmira mithum mesir blur mithum mes.
Blur with me, yeah.
अहिले daily stock जमेला छ अहिले robotic dance चालु छ जमेला छ
Cut for me, yeah. That's clear, Duga.
sir, त्यो PDF मा explain चाहिँ sir.
PDF नाले या. अनि म data मिथोमे या.
लेख्नु म थमे सर थन्दी थमे सर.
Ina. 제가 진 direct थाले explain गर्दा तुवेगा.
हामी जान्ने जुन छैन सर.
Then let's try with this one. Tuga. Okay. Now, in this one, as I've told you, okay, it's a buck regulator, okay, it's quite popular, and this means this is a circuit diagram, okay, where BJT is used. So this is a bipolar junction transistor is used. You have a load, okay. This inductors and filter inductors and capacitors are is used, and you have a load here. Now, so there are two mode of operations. Mode one is when the Q1 is switched on, and mode two is when the Q means when the Q1 is switched off. So during the switch on time at t equals to 0, so this it flows through the inductors, filter capacitors, and node resistor R. So during the mode 2 operations, the Q1 will switch off. Okay, at that period of time, it will be T1 will be T will be equals to T1. So in this period, the freewheeling diode will conduct due to the energy stored in the inductors. So during the mode 2 operations, that freewheeling diode will start on means operations. So because of the storage energy stored in the inductors, and so inductor current will try to flow through the L and C and the load and diode DM. So it will try to fall until the transistor Q1 is switched on again. So it means that it's just a switching on of a BJT power BJT and switching off of a power BJT. So you can use other type of power electronic device also. It's not we are focusing on means now we are just trying to see with the BJT, okay, but you can use even the power MOSFET, even in other type of power electronic devices also. But we are just focusing on the use of power BJT in this case. So it has a filter inductor, filter capacitors, and a freewheeling diode is also used. So it's just two mode of operations. Means mode one will when the BJT is conducting, and mode two when BJT is in off mode, means that it's not conducting. So the voltage across inductor L in general is EL is equals to di by dt. So if you see here, so can you see this PDF?
Yes, sir.
Because actually I thought of typing in the PPT. Okay, yesterday I had a meeting whole day. Okay, I could not type it in PPT. Okay, that's why I thought that PDF you can see through the PDF also. Is it okay
Hello, sir.
for me? More. No, you have to assume the inductor current rises from I1 to I2. This is what it means, that inductor current will rises from I1 to I2 during the T on means resistor T means like the power BJT on period. During this mode, it will rise from I1 to I2. It means it is rising from this level I1 to I2. So when the current rises from I1 to I2 in time T1, so this is the time period. During this time period T1, this current is rising from I1 to I2. So Vs it means that when the power BJT is conducting, the source voltage minus the load voltage will be equals to L d I2 minus I1 divided by T1. So which is change in the current divided by T1. So from here we can find out T1. T1 will be changed in the current into L divided by Vs minus Va. So the inductor current will fall linearly from I2 to I1. So during the time T2, it means that it will fall from T2 to T1 immediately during the time T1, means during the off mode. It is falling from I1 to I2 to I1. But during T1 time, it will rise from linearly from I1 to I2. So this is the load, means that the load current means it is constantly increasing from I1 to I2 during T1, and it will decrease from T2 to I1 to I2 during T2. So it means that during the off period, okay, then your load current, whatever it means that there will be no source voltage. So during that period of time, during that period, then it will be VA, means the load voltage, which the energy will be stored on the inductors and the capacitors. So we will find now T2 will be the change in the current divided into L divided by VA. So these are the equivalent circuits in a mode 1 operations, and this is the equivalent circuit of mode 2 operation. It means that it is flowing through this. So it will source voltage will be equals to load current. Means source current will be equals to load current. So in this case, you do not have a source, so it voltage will means that it will this freewheeling diode will start conducting whatever energy is stored, it will try to flow, and this will start conducting. So when del means that change in the current is equals to I2 minus I1. So peak to peak ripple current of the inductor L. So means it will start from I2 to I1. So peak to peak ripple current in this. So this change in the current will be del I will be equals to Bs minus Va into T1. So from here we can find out del I. From this equation, we can find out from equation number 9.31. So we can find out this del I from this. So this del I, so del I equals to Vs minus Va into T1 divided by L. So, and which is from this equation also we can find out change in, means the change in the current is equals to T2 into Va divided by L. So if we simplify this, del I will be this, del I is equals to these two equations. So substituting T1 equals to Kt. K is the duty cycle. If you know that, means that it means like T1 is equals to T1 plus T2 is equals to K. Means T means T, total T. So T2 can be 1 minus K into T. So this will yield the average output voltage. So VA can be written as the load voltage can be written as the source voltage into T1. This is the on period divided by total time period. It means that K is the duty cycle. So VA is equals to K into VS. So we can find out from VA is equals to K into VS. Means this is so we can find out the load voltage with respect to the duty cycles into VS, source voltage. So we have, if you assume the lossless circuit, so VS into IS is equals to VA into IA, then we can write this equals to KVS IA. So the average input current will be IS will be equals to K into IA. Now the switching period T can be expressed as T is equals to 1 by F. So which is equals to T1 plus T2. So total time period T is equals to T1 plus T2. So if we add this to T1 and T2, so whatever we have found it from here, T1 and T2, if we add this to total time period T, so if you add this two, then you will get del I L Vs divided by Va into Vs minus Va. So instead of, we can change this V value of this also, we can change in terms of a Vs, or V in terms of Vs, Va can be changed in terms of Vs. So you see here, okay. So Va can be equals to K Vs. So if you change Va into K Vs, and if you try to simplify this, okay, K Vs, Va is changed into K Vs, then we can find out in terms of, if you check out this common from here, KVS, then VS will be common. So this one VS will be cancelled, right? So you will get del I is equals to VS to K 1 minus K divided by FL. So if you try to find out the F is equals to T is equals to 1 by F. So change in the current. So how much is the change in the current in this circuit? So with the help of the Kirchhoff's current law, we can write the inductor current IL is equals to IC plus I naught. So which with this, so from this, we due to the, if we assume the load ripple current equals to del I naught, there will be a ripple current. So that is very small and it's negligible. Ripple current is, so we know that it means that I is equals to IC. Low inductive current is equals to capacitive current. So change in the inductive current is equals to change in the capacitive current. So average capacitor current will, which will flow into T by 2, T1 by 2 plus T2 by 2, which is equals to T by 2. Then IC will be, capacitor current will be equals to del I divided by 4. Now the capacitor voltage will be expressed in this. The capacitor voltage VC will be 1 by C IC into dt. If we integrate with respect to capacitive current with respect to dt, and plus the capacitor voltage when T is equals to 0. So we can find out the peak to peak ripple voltage of the capacitor. So del Vc is equals to Vc minus VC when T is equals to 0. So from here we can find out that change in the capacity voltage is equals to del I divided by 8 FC. So substituting the value of del I, okay, if you substitute the value of del I from here, so whatever we got this value, if we substitute this, the value of del I, then we can see this means del I, then we'll find out del VC is equals to VS into K. It depends on the duty cycle and depends on the source voltage and L and C and the frequency F, ripple frequency. So volt regulator requires only one transistor, means it requires only one transistor. In simple, it has a high efficiency greater than 90%. So its efficiency is 90%, and di by dt of the load current is limited by the inductor L. So it means that it has an effect on the inductor current. So the input current is discontinuous and the smoothing the input filters. So it means that it's smoothing the means that you must be thinking that there will be a smoothing of the, because you will not get a pure DC, means if you're converting a fixed DC to a variable DC. So you must be thinking that it's just input is DC or output should be DC, but there are other changes going on when you convert, when you try to regulate the voltage. So I think I'll stop here. Okay, today I'll not go to the next derivations. Okay, next one will be the boost converter. Just wait. Okay, I'll just take the attendance.
Sir,
Yes.
sir, I've not uploaded for unit 1 slides, not much, no, sir. Sir, if sir could upload some slides, sir.
Unit 1. I think I have uploaded
Yes, sir.
the unit 1 slide. It's not there.
There only, not much, sir. Like it's in this model description, no, sir. It's not much, sir.
No, the problem is, I think in the first unit, okay, I've taught you in the class itself. Mean I don't have a much PPT on first, because I taught you in the out here when you were here in the college only. But I'll try to
Yes.
see, okay, if there are other slides. If I have, I'll try to upload. But first unit
Okay.
is just a power electronic device. Okay,
Yes, sir.
it's just a power electronic device, and all these SCRs, different families of the thyristors, right? The characteristics means triac, diac, all this. Okay, GTUs, power MOSFET. I think power MOSFET and power BOGT.
First blood.
I think most of you must be having the, I know it will be difficult for you to go through this step, but try to look into this. Okay, whatever is possible, I'll try to upload.
Okay, sir.
Don't worry, the questions will not be that. Let's see, okay, how does it go? Okay, first let's try. Okay, how far we can be able to do
I'm
this.
gonna swing
Because
from the chandelier.
in our neighbor, I was
The
also explaining like this, understand what's your problem. Okay, I can understand. We also do complaining about all this, whatever that, okay. But we can talk to the higher
iPhone hack, how to make your lock screen transparent. Swipe up, lock your screen, hold the power button down, swipe down, and then release the power button. Boom. Now you can see everything. iPhone hack, how to make your lock. iPhone hack.
Everybody's more than you must have observed this one. And when I discuss with our colleagues here, now if you do not write everything in the
This piece
PPT
is
will
going
be
to
the
fit in
main-
there,
main
even though it
source
looks
for you.
impossible.
Is it right?
Let's see. Put this here,
I know most of the time
and
you just
then
refer
this
the
can
PPT.
go here. This one here.
So that
Put
key.
that
Even I
there.
discussed with our
This is really hard.
faculty here in our department. So I told
Maybe
them
that?
as far as possible if we can
Yes.
give, because some of you may not,
Go
when
here.
you do the online teaching,
There's
some
no
of
way
you
I'm gonna get
might
this
have
with
might have
TikTok.
internet problem.
How
You
long are
may not
TikToks?
hear, whatever we speak here.
Wait a
So
second.
at least you will get something.
Wait a
to do with the
second.
PPT.
Wait a
So
second.
let's try once.
Oh, now that would have
First
been
you
good.
need
I thought I had it.
Saturday. Look,
No. Oh, yes.
okay,
Oh.
this
Oh.
I'll stop here.
This piece
and I'll
is
try to
gonna fit.
upload whatever I have here. Okay, this I think next class will be on tomorrow. I think we will have a test. Bye.
Thank you, sir.